Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 11 and 12 physical sciences electrostatics. Today, in our exam prep, we're looking at the Gauteng province's grade 11 examination of November 2023. So, as is a norm, when we do past papers, it's important that we remind ourselves what's expected of us. Remember, all instructions are important. Right? All instructions are important. However, I'm not going to read all of them. I'm going to read just a few. So I begin with instruction number 8 that says, you are advised to use the attached data sheet. Of course, this is in the case you forget your formulas and your constants. Instruction number 9, show all formulas and substitutions in all calculations. That's very key. Instruction number 10, round off your final numerical answers to a minimum of 2 decimal places. So here, a further tip is that if in the middle of your calculations you have more than, let's say you have 10 decimal places when you press your calculator, please try to work with about 4 or 5 decimal places, and only your final answer should be to about 2 decimal places. Okay? So in the middle of your calculations, work with 4 to 5 decimal places, and your final answer is only 5. Instruction 11, give brief motivations, discussions, etc. where required. Remember, physical sciences doesn't have essay questions, so it's important that your motivations be very short. Okay? It's important that your motivations be very short. Okay? Then, instruction 12, I know a lot of us don't like it. Write neatly and legibly. Okay, write neatly and legibly. It's important that in as much as we get our understanding of different topics, we also improve our presentation, right? Our writing should be improved. Okay. All right, guys. Now let's get to this. The electrostatics, because this is grade 11 paper, is normally question 6, 7, 8, somewhere there. So let's see in this paper where it was. Okay, in this paper it's in question 6. So let's start. So question 6, a small metal sphere is placed on an insulated stand. The sphere carries a charge of -4 nanocoulombs. Right? It carries a charge of -4 nanocoulombs. Okay. 6.1, state the principle of conservation of charge. So this one is the one that says charges or charge cannot be created or destroyed, but can only be transferred from one object to another. Okay, let's write it down. Charges cannot be created or destroyed, right? But can only be transferred from one object to another, but can only be transferred from one object to another. Okay. 6.2, calculate the number of electrons in excess on sphere P. So the number of electrons that are in excess on sphere P is simply because sphere P is negatively charged. So it means it has more negative or more electrons. Okay? All right. So the equation that we use, we say N is equal to Q over Q sub E. The Q here is the charge of the sphere, which was 4 nanocoulombs. Nano means 10 to the 9. And the charge of an electron is given in your data sheet. It is -1,6 times 10 to the -19. Okay? This information is given, even the formula is given. Let me quickly show you. Was it? Oops. Okay, electrostatics. Oh, in this formula, they didn't give you the formula for charge quantization, but this is the formula, okay? But they did give you charge of an electron, which is a constant, negative 1,6 times 10 to the 19 coulombs. All right. Okay. Now let's get our answer. 4 times 10 to the negative 9 over 1,6 times 10 to the negative 19. We have 2,5 times 10 to the positive 10 electrons. Okay? We have 3,5 times 10 to the positive 10 electrons. All right. Now, a second identical metal sphere Q carrying a charge of positive 3 nanocoulombs is placed 4 centimeters from sphere P as shown in the diagram below. Okay, cool. 6.3. And by the way, guys, remember, this is an exam prep. You must make sure that 1 mark means you spent 1 minute on that question. So in this particular question 6, it's 15 marks. It means we must spend 15 minutes. So Coulomb's law in which 6.3, it says the magnitude of the electrostatic force, the magnitude of the electrostatic force between 2-point charges, okay, between 2-point charges is directly proportional. I will have to squeeze proportional here. Is directly proportional to the product of the magnitude of the charges. It's directly proportional to the product of the magnitude of the charges. Even if I didn't say magnitude, it's okay. Of the two charges, and inversely proportional to the square of the distance between them. Okay? And inversely proportional to the square of the distance between them. To the square of the distance between them. Right? To the square of the distance between them. Okay? I know others prefer magnitude of the electrostatic force exerted by 1 point charge on another point charge indirectly. It's okay. All right? It's still the same thing. Okay, guys? Perfect. Now, 6.4. 6.4. Let's see. 6.4 is the force that sphere P exerts on sphere Q, a force of attraction or repulsion. Are the charges like or unlike? They are unlike. So since they are unlike, it is a force of attraction. Right? It is a force of attraction. Okay, proceeding. The spheres are now brought into contact with each other and then return to their original positions. Calculate the new charge on each sphere. This formula, I've noticed that it's not given in your formula sheets. So it is Q sub nu is equal to Q sub 1 plus Q sub 2 all over 2. Even if you don't write Q sub 1, say you write Q sub P and Q sub Q, it's okay. All right? So here you do not need to ignore the sign of the charges. Sub 1, we will say it's negative 4 nanocoulombs, and sub 2 it's positive 3 nanocoulombs all over 2, isn't it? All over 2. So here I see that we have negative 0.5 times 10 to the negative 9 coulombs. That is the charge. We can leave it here. Okay? We can leave it here. So even if you say it'll be negative 5 times 10 to the negative 10, it's still okay. All right? It's still okay to say negative 5. Okay? It's still okay to say negative 5 times 10 to the negative 10 coulombs. It's still okay. All right. Okay, perfect. Now 6.6. 6.6 says calculate the magnitude of the electrostatic force exerted by a sphere P on Q. Remember, at this point now they have been brought into contact. So this electrostatic force is K Q sub 1 Q sub 2 all over R squared, isn't it? Good. So this K, if you have forgotten it, it's still provided. The Coulomb's constant is 9,0 times 10 to the 9. Okay? If you have forgotten it. So it is 9 times 10 to the 9. Close. The first charge is 0.5 times 10 to the negative 9. And the other one is still 0.5 times 10 to the negative 9. And then what is the distance between them? Where 4 centimeters. If you like, you can write 0, if you like, you can write 0,04, or centi means 10 to the negative 2. So this is 4 times 10 to the negative 2 square. Okay, let's get it. 9 times 10 to the 9, open bracket, 0,5 times 10 to the minus 9, close bracket, square, over 0,04 square. What is our answer? Now our answer, calculate the, okay, our answer is, what is it? Our answer is 1,41 times 10 to the negative 6 newtons. Okay? It is 1,41 times 10 to the negative 6 newtons. Okay? Perfect. They said the magnitude, so it's okay. I don't have to say attraction or repulsion. Now 6.7. 6.7. Let's see what it says. 6.7. By what factor will the magnitude of the force in question 6.6 change if the distance is halved? So R2 is half of RY. All right. If you recall, guys, you have said F is equal to 1 over R squared. Remember, this is because you said F is directly proportional to the square of the distance between the objects. All right. So now check this out. So if it is halved, it will be 1 over 2 squared. Your calculator will tell you that this is 4, isn't it? This is 4. So to answer your question, here I just showed you how you get your answer. To answer your question, they said by which factor? It'll be 4 times. Okay? It'll be 4 times. If you like, it'll be 4 times. That's the factor in which the magnitude of the force in 6.6 will change. It'll be 4 times bigger than what it was. Right? Happy? Great. So we were done with this question in less than 15 minutes. Mind you, we took about 2 to 3 minutes reading instructions, introductions, and stuff. So check this out. We are on the right track. You see, now you will be able to finish your exam on time. Now let's go to question 7. Now question 7, this one deals with electric field strength. P is a 1.5. P is a 1.5 meters from a charged sphere Q. Okay. The electric field at P, this is interesting. Let's say this is a point P, and then this is your charge. What do we call it? Let's call it Q. Okay. So the electric field at P is 6 times 10 to the 7 Newton per Coulomb directed towards Q. Directed towards Q. This means Q must be negatively charged. All right, let's see now. 7.1. Define the term electric field at a point. It is the force experienced per unit charge, okay? At that point in the field. Okay? So it is force. It is the force experienced per unit charge at a point in the field. At a point in the field. Okay, perfect. 7.2, 7.2, draw the electric field pattern caused by charged sphere Q. Remember what I said to you? I said to you, when you look at the electric field, they said the electric field strength is directed towards Q. If it's directed towards Q, you can see that it means the charges are coming inside Q. And this can only be a negative charge. So let me just write it as a Q, and then I'll then draw it like this. Okay? And then I'll say the charges are like this. Okay? I will say the charges are like this. This is to say it is a negative charge. Alright? Even if you don't write this Q, it's okay. You can say negative, but I prefer to write, in fact, let me write the Q. Okay? Let me write the Q like this. Okay? But otherwise, it's a negative charge. So even if you write negative inside this circle, it's okay. Okay? Okay. Now let's go. 7.3. 7.3 says calculate the magnitude of the charge. The magnitude of the charge on sphere Q. So what we know, guys, what we know is this. We know that electric field strength is equal to force divided by charge. But here, we are not really, we don't have the force, all right? So since we do not have the force, what can we do? We can then use this kq over r squared, all right? What is the electric field strength? Electric field strength is 6 times 10 to the 7, and obviously Coulomb's constant is 9 times 10 to the 9. Then the charge, we do not know. The distance between the points was 1.5 meters. So 6 times 10 to the 7 divided by 9 times 10 to the 9 over 1.5 squared. What is our answer? Our answer, I see Q is equal to 0.015 coulombs. I can leave it like this, but we can also leave it as 0.02 coulombs. Okay, we can also leave it as 0.02 coulombs because we work with 2 decimal places. Okay, but I'm gonna leave it here. I'm gonna leave it at 0.015. Okay, all right. Now let's see 7.4. 7.4. This is a part that is confusing to most students, and even when I look at some of the memos, I see some get it, some do not get it. All right, so let's see now. Another charged sphere R having an excess of 10 to the 5 electrons. You see, it has an excess of electrons. What does it mean? It means it is negatively charged. Remember, guys, if it has an excess of electrons, it means it is negatively charged. Okay, it is negatively charged. So it is now placed 0.75 meters to the right of Q. All right, calculate the net electric field at P. Now here's the thing, guys. I want to show you. If you look at, let's say this is P and then this is Q, we have showed you. Q is negatively charged, isn't it? Q is negatively charged, so they will be like this. And then again, the very same point, P, and let's say R. They said it has an excess of electrons. If it has an excess of electrons, what does it mean? If it has an excess of electrons, it means it's negatively charged, right? It means it's negatively charged. So our vector here will be like this, guys, will be like this. It'll be, okay, let's say this is E of Q and then E of R. Okay, or if you like, it can be like this. I don't know which one is smaller and which one is bigger. Let me see. The distance, okay, this one, the distance is bigger, so it must be smaller. All right. All right. Q, the distance R, and then of R, the distance. Ooh, hold on. No, Q, the distance is smaller. Yes, Q, the distance is smaller. So this must then represent R, and then R, the distance. No, man, what am I saying? Q, the distance is smaller. So if the distance is small, it means electric field strength will be higher. So this must be Q. Okay, it will be larger. and the distance between point P and R is bigger, electric field strength will be smaller. So it can be like this. Do you guys see this? All right. So to answer the question, we then say E equals KQ over R squared. Now E sub net will be E of R plus E of Q. I have seen some memos, they will say some other things, guys, but trust me, this is what we do. All right, let's see now. For R, let's see, for R, what do we say? For R, we say this is 9 times 10 to the 9. What is the charge? The charge R is, oops. We can't proceed as yet. We do not know what the charge is, right? We do not know what the charge, do we know what the charge is? We do not know. So now for E, let's begin by saying N equals Q over Q sub E. Therefore, we can therefore say this is Q equals N Q sub E. Then it's fine. E net equals E of what? We can say it is equal to E of Q plus E of R. It doesn't matter. All right. So sorry guys, I need to write this because I do see that I'm gonna see flames if I don't. Right, I see I'm gonna see flames if I don't. K, and here we're gonna say it's Kn Q sub E over R squared, or R squared capital R. I think it's better this way. All right. Actually, let's go. 9 times 10 to the 9. Ooh, no. This one is given. Electric field strength of of Q is given as 6 times 10 to the 7. And then of R we do not know, so it's 9 times 10 to the 9. And we have 10 to the 5 electrons. Remember, it is excess. And then the charge of an electron is 1,6 times 10 to the negative 19. And what is the distance between point P and R? It is 1,5 plus 0,75. It looks like it is 2,25. So 2,25 squared. Let's see. So 6 times 10 to the 7 plus a fraction. 9 times 10 to the 9 open. 10 to the 5. Oops. 10 to the 5. And then 1,6 times 10 to the negative 19 over 2,25 squared. What do we get? What do we get? We get, let me see how many zeros. 60 million. So we get 6,0, or you don't have to say 6,0. 6 times 10 to the, is it 7 zeros? Yeah, 6 times 10 to the 7 Newton per Coulomb. Where? With what I'm seeing, it is going in the same direction. So it is, did they say the magnitude? No. So it is going to the right. Okay, it is going to the right. The net electric field strength is to the right. Okay, guys? The net electric field strength is to the right. Okay? And this is how you attempt your questions. The game changer for this particular question, guys, is you being able to get the vector of your electric field strength at point P. Okay, and yeah, so this is it, guys. Let's see. We were supposed to spend about 28 minutes on this question, and we spent less than 28 minutes. And remember, if you would like to keep in touch with us, follow us on our social media platforms. The link is given in the description of this video. That includes WhatsApp channel as well. And again, if you have enjoyed this video and you would like to see more of us, please subscribe. And if this video was really that helpful, please like and share with your mates. With that being said, ours ends here, and all the best with your examinations. Bye bye.